Hi, I'm Andrew, and today I'm going to show you how to field fabricate a 4-piece duct transition. The method I'm going to show you is going to take what is normally a very complex fitting and simplify it. We're going to use basic hand tools today. You're not going to need any complex equipment. Let's go ahead and get started. First thing we need to determine is whether or not we're going to do a 4-piece transition or if we're going to have this fitting fabricated in the shop another day. So there's two scenarios. One would be if I'm doing a new construction job and I've got a duct that shifts like in a truss or something and there's an offset that occurs there and I can easily measure that offset. I may actually just order that fitting and work on something else for the rest of the day and just come back with a pre-made fitting and put it in. But most of the time, it's an air handler change out or something that has a weird dimension to it that's kind of hard to measure. So what I've done here is I've simulated a normal case where you'd want to use a 4-piece transition. I've got an air handler here. Let's envision that this is in an upflow in a closet at someone's house. I'm on a change out, so I've got one day to start and finish this project. I don't have time to order a fitting from a shop or wait on it. Also, this transition changes up on 2 dimensions here. This would be pretty difficult to measure. It's very quick for me to field fabricate this, so I'm going to go ahead and make the decision that I want to field fabricate this 4-piece transition, so that's what we're going to do. So because this is a field fabricated transition, I'm going to use very little tools to try to get this done. I'm going to act like I forgot my layout ruler for the day, so I'm going to be using S-lock to draw my straight edges. I don't have a sheet metal brake because we're doing a change out and we only had one truck and we couldn't fit the sheet metal, the portable brake on that truck. So I'm going to be doing all my bends with either hand tongs, folding bar, or S-lock, and all my cuts with snips and just basic hand tools. First thing I'm going to do is I'm going to add S-lock to this fit, and it's going to do a number of things. One, it's going to stabilize this a little bit. It's not going to be shaky like this. 2, it's going to give us something to slide our adjoining piece of metal into, and it adds a significant amount of strength. When I cut this, I actually do it by hand. I don't measure the pieces out. I use my thumb and I actually mark. And I'm actually making the S-lock slightly smaller than the side. That way when I go to fit the metal, I'm not fighting it. When I cut this, I normally cut it almost all the way through. Then I bend it like this and cut the next piece. This allowed me to make a quick copy of the front. So I got the front and the back piece now. And I'm just simply going to slide these on. And I'm going to add one more here and one more here. So common mistake made is when people measure their vertical dimension for this piece of duct, they just measure up and down between these 2 points. And the distance from here and here, perfectly vertically up and down, is less than running at an angle this way. So I'm going to start by measuring my vertical here. From this point where my marker's at to the bottom of my S-lock there, and I have 20 1/4. All right, now I'm going to round down to 20 inches. And I'm going to have a 1-inch lip here, so I'm going to add an inch for that. And I've got a 1-inch lip here that needs to be added to go into the S-lock. So I've got 20 inches here, plus an inch, plus an inch. So my vertical dimension on my piece of metal is going to be 22 inches. Now that we have our vertical dimension, we need to determine our horizontal dimension. And the biggest thing with this is this can be as long as you want it to be. It just has to clear this side of the fitting and this side of the fitting. So if this air handler was completely offset from the duct, you'd need to measure all the way from over here to all the way over here. So it's kind of hard to explain and hard to get a camera shot angle on it. So we're going to just do a couple different passes at this. You'll see me make this fitting once. And I'm going to make it again on the front side, and you'll get a gist for what's going on here. But basically, I need this dimension to be wide enough to pick up down here as well as up here. So for this one, I'm going to actually measure from this point all the way to here. I'm going to make it 24. I actually only need it to be 22, but I'm just going to go a little bit bigger to where if I was off slightly, I have enough metal to work with. So now all I have to do is simply cut out a piece of metal 24 by 22. I'm going to use a marker on this and not a scratch tool because I'm acting like I'm on a project on a job site, and I'm normally not gonna have a layout table. I'm actually gonna be working on their driveway or on their lawn on a surface that's not solid. So this may seem very easy right now, but on the field, you're out in somebody's yard, you've got sun beating down on you, the metal's reflecting back into your eyes. You don't want to use a scratch tool for that. The marker is what we use on this. It has a thicker line than what a scratch tool would, but it is what it is. So I'm just simply going to mark my 2 points, 22. I like to use arrows. You can use dashes. I just find the arrows are quicker. And I'm going to snatch up a piece of S-Lock here. Because I forgot my layout ruler today. I actually have one here, but I'm going to act like I'm on a job. I forgot my layout ruler, but I do have S-Lock. So I'm simply going to mark my lines out here. Straight snips here, we call these bulldogs. I have no idea why. I've got my cut piece of metal here, and I'm 22 this way, 24 this way. If I take this and put it right here, it's too long right now because I need to bend my 1-inch lip down here. And I also am going to put a little offset up here just because I'm going to. You don't really have to, but it's a little cleaner. I'll show you in a second. There's a couple different methods on the field that I can make these bends. Remember, I didn't bring a portable brake today because my truck, after loading up the air handler and the condenser and all that other stuff, I didn't have room for it. So I've got 3 ways that I can make a 1-inch bend on this metal, actually 4. We've got a folding bar here with a 1-inch lip. This normally makes the cleanest, tightest bend if you're on a very good flat surface and your metal doesn't exceed the length of this folding bar. I've got this 22 dimension here. When I make this bend, I'm coming up a little short. There's a way I could do it and train it, but this probably isn't the best tool for it. The next tool I have, which is most commonly used, is hand tongs. This does the job. It works. You have to, what we kind of call train the metal, where you bend a section up about 45 degrees, then you bend the next section, the next section, the next section. So it'll make a 1-inch lip, but there's going to be little kinks on that 1-inch lip all the way down. Nothing wrong with it. We're going to insulate this. But something long like this, I personally like S-Lock because this will flex while I'm making the bend, which will allow me to bend a certain portion and keep working it down. And in the end, I'll have a nice clean bend. The problem with this is it takes a ton of hand strength. Some people just can't do it. Or if you get into like 24 or 22 gauge metal, it's going to be near impossible. This is 26 gauge metal. I'm pretty sure I can make this bend pretty clean. So I'm simply just going to take this S-Lock here, and I'm going to get on the corner of the S-Lock there. I'm going to hinge down. I'm going to make sure that's all the way snug there. And I'm actually taking my hand right here, my thumbs right here, and I'm going to do a bend. I'm going to move down a little bit, bend, move down a little bit, bend, and I'm just going to keep working this all the way down here, slowly getting that 1-inch bend. Like I said, the folding bar method is faster and cleaner, but that folding bar isn't long enough. Some people would debate with me if this is the best method. That's fine. You find your own method and you use it. This works for me, so I'm going to do it. You like hand tongs? Nothing wrong with that. Use hand tongs. So now what I'm looking at is I'm looking at my angle here. This actually shoots up at a little angle here. So I'm a little bit more than a Well, I'm less than a 90-degree bend actually. So I need to come back slightly on this. So there's my 90 bend. Not perfect, it's not bad. I went a little too far though, so I'll use hand tongs here to train that back just a little bit. And we got this bend here. I'm gonna put that there. That's my first bend. So I'm probably fine with just this one bend here, and this is such a slight angle that it's probably fine. I'm gonna go ahead and put a little bend here, mainly not for looks, but anytime you add a bend to metal, you're adding strength. So I'm just gonna go ahead and just put a little bend there. Give us a teeny bit of strength. Make sure I'm bending this the right way. Yep. I want to go that way with it. We got a tiny bend there, nothing drastic. When I hold it up there, it's straight right here. And this is a nice clean 90. All right. So that was the hardest part of our transition right there, is determining your dimensions and making that. Now, really all you have to do is mark your 4 points here and then connect the dots. So I'll start with my bottom piece. So on my bottom piece, my next piece of metal is obviously going to run right on this plane to this plane. So I'm going to have like a 1-inch lip right here where these X's are shown. And I'll have a 1-inch lip right here where these X's are shown. So that said, my bottom mark, put a mark right there. My other bottom mark, put a mark right here. All right, one more thing I'm going to do so I don't forget the orientation of this metal. These bends actually show me what the orientation is, but just to get in a habit, I'm going to write B right here for bottom. There's the bottom of my transit. If I want to, I can put a T here. There's the top. You know what I mean? And I'm also going to mark the top here, right there and right there. And I'm going to connect those two dots. So let's just connect those two real quick. So I've got these two marks here that have given me the angle between these 2 points. And the next thing I need to determine is do I want a 1-inch lip here to screw to, or do I want it on my next piece of metal? If I'm working in a closet, let's say this is the front of the closet. I'm standing at the front of the closet and there's a wall right here, right? And I can't get my drill in here to screw this way. I obviously don't want my 1-inch lip to exist on this back piece because I can't physically screw into that 1-inch lip. So what I do is I'd actually have the 1-inch lip on this side so that when I'm putting on this piece of metal, I can screw this way because I'm standing at the front of a closet open. There's a wall here. So what I'm getting at is I'm marking this out now and I have a choice. There has to be a 1-inch lip on every corner, but it can be on either this piece or this piece. And I'm going to determine what side makes the best sense for my application. If this is the front of the closet, I'm going to want to screw this way. So I'm going to want to add a 1-inch lip to this piece of duct. One other thing that's great about S-Lock is it's about 1 inch in width, maybe a little bit longer, but that's okay because we're just making a lip to screw to. I'm just going to simply, and I could have actually created the 1-inch lip when I was drawing this first line, but I wanted to pause, and for the purposes of this video, I didn't go that far. But if I was marking this line, I could have just simply come on the other side and boom, there's my 1-inch lip, you know. Then do the same over here. There's my 1-inch lip. All right, so all we have to do is cut this out. I'm going to put a little mark here just to show a notch. I'm going to explain that here in a second, so don't mind me too much here. We're going to cut the edge of this off. Now I'm going to notch this right here. Keep in mind, if you're on a job site and you start notching duct, you want to find a place to put your notches because it'll just make your cleanup at the end of the day a whole lot better. Basically, this is my notch here, and when this duct sits flat on the unit, this duct is going to bend in like this. And if I don't notch this, because it's running at an angle here, this metal will actually be hitting this side of the unit here. So that's the reason we notch, and we turn our notch up, is to clear material when this is making a bend. Kind of hard to explain, but when you start bending metal a lot of times, you'll run into a situation where you didn't notch deep enough or something. You'll learn real quick why a notch is important. So I'm going to notch all 4 corners here. We've got our transition piece here, and we're going to just check our marks. Everything marks out well. When I measured this dimension here, this is actually like 20 1/4, but I made this piece 20. I did that on purpose. If this duct ran at a slight angle or something, and I pulled my measurement from one side, let's say it was 20 here, but it was 19 7/8 over here, it's going to make it very difficult for this piece of metal to get in there, and it would probably have some flex after it was done. So because I have S-lock here, I've got an inch to work with. Like, I can have this metal up to probably 3/4 of an inch short. Like, see how I'm short, but it's still in there. It's still good. I mean, I'd like to be in a little bit more to where I can get a screw in it, but give yourself some play here to get your fitting in and not have to fight. We're going to discuss cross breaks real quick. So we've got a piece of metal here. This actually probably doesn't require a cross break because it's a very small dimension here. There's not a lot of surface area. We also have, remember I explained anytime there's a bend in the metal, it increases strength. So this is going to end up being a 1-inch lip here, which is going to add some strength. This is going to be a 1-inch lip here, which is going to add some strength. We've also got a bend here and a bend here. But let's say this is a bigger piece of metal. We need to put a cross break on it. And what that does is when the unit cuts on, if there's flex in this metal here, you might have a popping noise that occurs or something, you know, when the unit cuts on. This is more apparent on a return that's probably undersized or something, where there's a lot of static pressure. People have had problems where they cut on their unit and there's a pop noise that occurs or something like that. So that's where a cross break comes into play. It also adds some structural integrity, but we're on a job site. We don't have a portable brake. We don't have a full-size brake. We've got no brakes. So how do we put a cross brake into this? And I want to show that you can do a cross brake on a ton of surfaces. The sharper the edge is going to obviously make a cleaner bend. If this is being insulated by fiberglass, having a slightly bumpy edge, it doesn't really matter. You're not going to see it later, so it's just a cosmetic thing that's getting covered up anyways. I'm looking at the side of this plasma table right here, and this is very similar to the edge of a flatbed trailer, which is something that we sometimes have on a changeout. You know, it's very plausible that there'll be a flatbed trailer, or there's been people that have carried around a piece of angle iron and they'll put it on someone's front brick stairs or something where it's a solid surface. So to do this, I'm going to line up the corner here and the corner here, and I'm going to put a lot of flex on this metal with my left hand. I'm going to keep this very tight, and I'm going to try not to let this metal shift. This can be hard for me to do on camera, and I'm going to make sure that I don't pound right here on this 1-inch lip because I could cut myself. But I'm simply going to come here and I'm going to pop right on the edge of this plasma table here. So what I've got there is a slight cross break right there. But let's say we don't have a flatbed trailer. What are we going to then use? Well, I looked around the job site So I've got a 4x4 here on the job site. It's got a nice right angle to it, and I can simply use that to make a bend, you know. So I'm gonna take this here. I'm gonna line up my 2 points. I'm gonna put some flex in it. See how I did that? The hardest part to get it to look good is gonna be right where these two intersect, because they're just fighting against each other. So I'm gonna start at one edge. So you get a little lower to this. Trying to make it where y'all can see, this is difficult. Here's our cross brake. So that's field fabricated cross brake with no sheet metal brake, using a flatbed trailer or a 4x4. I showed you how to make a 1-inch lip with a piece of S-lock here. I'm going to show you, just for the purpose of the video, how to do it with hand tongs. And on these hand tongs, they have notches. 1/4 inch, 1/2 inch, 3/4 of an inch, and 1 inch are what these notches represent here. I'm wanting to do a 1-inch lip. So I'm going to come to my metal here, and I'm going to line up right on that 1-inch notch there. I'm squeezing tight. I'm going to put my hand here. I'm going to just do a little bend. I'm not going to go too much farther than that. And I'm going to come in, but right past that bend, and do it again. And I'm just going to repeat that process, training this metal as I go down the seam. Now that I've got this metal trained a little bit, I can start working a little bit faster. So this is my completed 1-inch lip using hand tongs. And as I said earlier, when you use hand tongs, because the hand tongs are only about 4 inches wide or 3 inches wide or whatever that is, you end up with these little kinks running down the metal. Nothing wrong with it because it's getting covered up. But this is personally why I like, S-lock or something like that. It's just a little bit of a cleaner field brake is what I'll call it. I'm going to go back to my old trusty method of using an S-lock. It's faster, cleaner, better in my opinion. We've got our first transition piece here bent and ready to be screwed together, but this is a perfect opportunity for an AGL mechanical exclusive tip. And that is, before I bolt this on, I can cut this pattern onto fiberglass insulation so that I can easily insulate this fitting later when I'm done with it. To do that, I'm just going to simply have a piece of fiberglass here, lay this pattern right down on it, and I'm just going to simply copy my fitting right on the fiberglass. If I want to have my staple, my 1-inch lip side on this as well, I'll add a 1-inch lip to staple to on this side, 1-inch lip to staple to on this side. So I'm not going into detail on how to do this. I'm just simply showing you that this can be done, and it should be done. The steeper your angle gets, the harder it's going to be to insulate. You could insulate it later with just a large strip out, but then you're going to have to tuck your ends and do all that. If you do it piece by piece, it's going to lay perfectly flat and contour your fitting perfectly. So I'm just going to go ahead and cut this pattern, cut my 1-inch lips, and then I'll write on the back of this that it is my right side transition piece, so I know later which piece of duct it sits on. And I'm just going to write on the back of this right side transition piece. You know, right side. I'm going to mastic this solid, so this doesn't matter if you weren't masticing it solid. Don't write that. To fit this together, I'm going to start with the piece of duct going into the S-lock, and I'm going to come in at an angle here and put my corner in, right like that. And then I'm just going to leverage up right here. Slides right in. I'm going to make sure I'm straight this way. And then I'm going to, you know, see how I'm a little shy here at the bottom? I can just pull down. Remember I told you I cut this slightly short to give me room to work. And I'm just going to go ahead and drive a screw down here at the bottom and start at the back corner. Put one screw here at the front. All right, now I'm going to discuss drilling through S-lock. When you drive a screw in the center of S-lock, you compromise its strength. You're going to it'll actually put a bend here. It'll allow that metal to then flex. So we don't want to screw S-lock in the middle. You can screw it on the two ends, and because that's going to stop your duct from pulling out, it doesn't need a screw in the center. I see this a lot with rectangular duct. We use S-lock when we're connecting rectangular duct for strength on the duct, you know, so the strength doesn't bow here. When you screw that, you severely compromise the strength. But another thing you can actually do, because there might be weird situations where you have to screw S-lock. It's always a weird scenario. But I want to show you one thing that can happen when you drive a screw through S-lock. I'm going to try to exaggerate this, but you see how it opened up this little bend right here? That, if it's a certain shape and it's in the airstream and you have a hard pipe duct system, you've created a whistle. And literally when that system's running, turbulent air can actually create a whistle on this. It's rare, it doesn't happen often, but I have had this cause issues in the past. So if you ever do have to screw S-lock in the middle, which it should be very rare, you really shouldn't need to, you have to make sure that that gets all the way driven in like that. So in this application, we don't need to screw it in the middle. We can simply screw our two ends. Make sure I'm lined up here. And I'm going to keep my finger away, but that's pulled it in all the way. I'll put one screw here. I showed you how to make one side piece here. To speed things up, I went ahead and made these other two sides. And I'm just going to touch on a few things right here before we close this up. There's an angle here that's a little steep, and I could probably get my drill in here to screw this lip here. But I want to just note that there's going to be situations where this is a very steep angle and you can't get your drill in there. And if that's the situation, it's okay. You just want to build this piece tight. You don't want to have it loose, and you want to make sure that there's somewhere here to screw to, somewhere here to screw to, somewhere here, and that this bottom section is tight. Another reason for possibly not screwing this down is there could be an evaporator coil right here, like a water furnace geothermal unit, the vertical units. Their evaporator coil actually runs up the side, and it comes all the way up to the top of the unit. And if you drive a screw right here, you've put a hole in your coil. So what we normally try to do is not even build our offset near that, but there might be a weird situation where you're right over the coil and you can't screw it if that's the case. So I just want to note that it's okay to have this one seam not screwed. If you can't, that's okay. To close this up, I'm going to pull measurements for my last piece here. I'm going to start with my vertical measurement. I'm going to touch on this again. We don't want to pull straight up and down. We want to follow the angle that our transition piece is going to go in at. In this case, it's 20.5 like this. If I measured it like this, it was 19 3/4, so we were off by 3/4 of an inch. So my measurement to the S-lock is about 20.5, plus I'm going to add the 1-inch lip here, plus I'm going to add the 1-inch lip here. So I have 22.5. My width, I want to make sure that I am longer than both my top and bottom. It could be as long as I want it to be. The longer it gets, the harder it is to work with, but it just needs to be longer than your fit, and we're gonna trim it up later. So in this case, I'm just gonna hold my tape here, And I'm gonna say, oh, 24 covers both the top and the bottom. I'm got plenty of enough metal to make these marks and cut it out. So I have my last piece here. It's not cross broke yet, but I do have my 2 bends here. And this was cut 24 wide by 22.5 tall. And it's a good tight fit. I'm gonna start with my S-lock here, just like we did before. This being the last piece, it's normally pretty tough with this weird angle, but I'm gonna take it and bend it like that. And I'm gonna pop it right into place. And as you can see, it's pretty solid just like it is. That's why we can get away without screwing here. When you're making this tight, you might actually go a little too long and it might be too tight. Just trim off what you need, no problem. Now that this is in place, all we have to simply do is take our marker, push down tight, and mark this edge here. Then I'm gonna come around here and I'm gonna mark the other side. And I'm gonna take my piece out again. I've got my marks here. I'm gonna cut that. We're gonna fit it together. We're gonna put some cross breaks on it. Now that you know the completed process of how to build a 4-piece transition, a couple tips I want to go over real quick is make sure that you need to determine when you want to use a 4-piece transition and not actually just make this in the shop, because it's always easier to have this made in the shop. The 4-piece, it's great. It is slow and time consuming. Also, when you're doing this, you want to make sure you have the proper length to actually fabricate a transition. The closer this duct is to this unit, the shorter your transition is, the harder it's going to be to fit all this together. And also, when you start getting into angles, the steeper the angle is, the harder it's going to be to get it together. You want to be careful not to screw coils. So if we're doing a 4-piece transition on a package unit, there's normally always an evaporator coil. Goodman's bad about it. They run an evaporator coil right in between the supply and return openings. So you got to be you got to know where that evaporator coil is. You should always know where the evaporator coil is and don't screw it. Water furnace units, they have one that you go down into, all that good stuff. That's a major time loss and affects your product if you hit the coil. Pay attention to your lip sides. When you're laying this out, don't just put a lip on each side. Try to determine what side of each transition piece gets the lip so that you're thinking forward in where you're going to be screwing and can you actually get your drill in to make that screw. Lastly, I touched on cutting insulation patterns as you made this transition. I only did one side just because this is training. All that's left here, if this was on the field, we'd seal it, we'd then insulate it. This isn't a very hard transition to insulate, but some that are steeper angles would be very difficult. But remember, I went back in the video and I wrote right side on this, and I've got my pattern here already cut. So if I continued this process when I was laying out all 4 of these pieces, I would simply take this one piece here, I would tape it, then I would be putting this pattern right here like this, and as you see, it fits perfectly here. And I would be folding over my edge, and I'd take my staple gun, pop, 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 screw this, tape it, mastic it, it would look perfect. Hope you like this training. Don't let this intimidate you. This is a very simple process. Just once you know the method and you repeat it, you will get better at it. Like the video, subscribe to the channel, feel free to leave a comment in the comment section, and remember, quality is your reputation.